Let's do a practice problem where we calculate molecular formula from empirical formula. Propylene contains 14.3% hydrogen and 85.7% carbon and has a molar mass of 42.08 grams per mole. What is its molecular formula? The first thing we have to do in this problem is calculate the empirical formula, and then from that we can get the molecular formula using the molar mass of the compound. The first step in all of these problems is to find the amount of each element in grams. We are given percentage, so we can assume that we have 100 grams total. If we have 100 grams, that means that the percentages just convert directly to grams, so that we have 14.3 grams of hydrogen and 85.7 grams of carbon. Next step is to convert the grams of each element to moles. So we have two elements, hydrogen and carbon. This is a one-step conversion of grams to moles for each. So I have 14.3 grams of hydrogen, 85.7 grams of carbon. The molar mass of hydrogen from the periodic table is 1.008 grams per mole. The molar mass of carbon is 12.01 grams per mole. We have it set up so that grams cancels and we're left with moles. Doing the math, 14.3 divided by 1.008 is equal to 14.2 moles of hydrogen. And for carbon, 85.7 divided by 12.01, that's equal to 7.14 moles of carbon. You can probably guess, looking at these numbers, what the ratio is going to be, because 14 is twice 7. But we will do the math to convert to whole numbers by dividing by the smaller amount of the two. The smaller amount of the two is the 7 moles of carbon, so we're going to divide both of those moles by 7.14. So we're going to start with hydrogen, 14.2 moles divided by 7.14 moles. Doing the math, 14.2 divided by 7.14. It's close enough to 2. So it's very, very close to a whole number. So in this case, we're going to round to the nearest whole number. We don't have a fraction that is easily converted to a whole number by multiplying. So we round. And now we're going to have carbon, 7.14 moles divided by 7.14 moles. So we don't need to do the math. That's going to come out to be 1. So just like we suspected, it's a 2-to-1 ratio of hydrogen to carbon. So that is going to give us our empirical formula. So our empirical formula, we use the 2 from above as the subscript for hydrogen and the 1 for carbon, which is not shown. So the next thing we need to do now that we have the empirical formula CH2 is to calculate the molar mass. So I'm going to use my little grid here. I have carbon and hydrogen, and there's 1 carbon and 2 hydrogens. The molar mass of carbon is 12.01 grams per mole. The molar mass of hydrogen is 1.008 grams per mole. And we multiply across and add down. So multiplying across, I get 12.01 grams carbon, and then 2 times 1.008 is 2.0.016. Adding those together gives us 14.026 grams per mole. If we want to, we can round that to 14.03, which I will probably do, so that we keep 4 sig figs. Now we have to calculate N. N is equal to the molar mass of the molecular formula divided by the molar mass of the empirical formula. This is just going to tell us how many times the empirical formula numerically fits into the molecular formula mass, the molar mass of the molecular formula. So if we scroll back up, the molar mass given to us for the molecular formula is 42.08. So that's what we put on the top, 42.08 grams per mole. And we're dividing that by our 14.03 grams per mole we calculated in the step above for the empirical formula. Doing the math, 42.08 divided by 14.03, and that is rounded to the nearest whole number, which is 3. So that means that the molecular formula is 3 times the empirical formula. So we multiply our CH2 by 3. So we multiply the subscripts in the empirical formula, each of them by 3. So the carbon subscript is 1, so that becomes a 3, and then 2 times 3 is 6. So the molecular formula for propylene is C3H6.